Hi, my name is Verona Williams, and I'm recording the video on how to divide a polynomial by monomial for FNMT 17. So I have two problems here, and basically the first step of how to divide a polynomial by monomial is to split the terms into just all of the terms in the numerator as just one piece over the denominator. So that's the first step, is to split the terms. And what that'll look like is we just take 24x squared y squared over the denominator, which is negative 6x squared y squared. And now, because this is a negative in the numerator, or a minus sign, we're just going to bring it right down. Minus 16x squared y squared, or just y, over, again, negative 6x squared y squared. Another minus sign, so again, just break it down. Minus 12x y cubed over negative 6x squared y squared. All right, and so from here, the second step, or what I like to do first, is to divide or just simplify the coefficients. And I just find that easier because it's always what you write first, so we may as well divide or simplify those first. So this one is pretty nice because 6 goes evenly into 24 4 times, so we can just cross that out and make this a negative 1 and this a 4. And then in the second term you have, so this, we do also have to remember that this gets, this minus sign makes this 16 negative. So what, and that's important just for writing the final product. So because these don't, 6 doesn't go equally into 16, all we can do is just simplify, and that is just taking a 2 out of each of these. So we've got a negative 3, and if you divide 16 by 2, you get 8. And then finally, we have negative 12 and then negative 6. So pretty easy there. We can just get rid of that by going negative 1 and 2. And then so I just like to write these down so that I don't lose track of everything. So I'll just really quickly write, so because we also just have to keep in mind that the division rules for other problems still apply, so you just have to make sure that if there's a negative sign in either or both the numerator and the denominator, that gets reflected in the answer. So because this is a negative 1, we've got to make, 4 is being divided by negative 1, it's got to be a negative 4. So negative 4, and then we've also got a negative 8 here and a negative 3. So because we're going to have to keep that into a numerator and denominator position, we can put a plus sign and keep that so we don't have to write any of the negative signs. And then here we'll just bring down, again, we have a negative and a negative, so just a plus will work for 2, and I won't write the negative 1, just like I haven't written it down here, but that just keeps me kind of organized while we move on to the third step, which is just to apply the quotient rule of exponents to the exponents that are in the variables, which is essentially just subtracting the exponents from the variables. So the way that I like to do it is just go again by just along in how the problems are written. And here we see the first variable is an x squared and an x squared. Because 2 minus 2 is 0, and that would just make this whole x variable a 1, we don't have to write it. I just cross them out and not even, just, you know, so that I know in my head I don't have to write them in the final answer. And then the same thing applies with these y's here. So a y squared and a y squared is basically a 2 minus 2, which just equals 0, so we don't have to write them because all variables to the 0th power equal 1, and we don't have to bother writing the 1 in this problem here. So again, it's an x squared over an x squared, which just cross each other out, so we don't have to worry about writing this one here. But with this y, we see that there is a larger exponent in the denominator. And as long as that exponent is positive, we know that wherever the larger exponent is, that's where the exponent is going to stay in the problem. So it's in the denominator here, it's going to be in the denominator here. And what I just like to do is kind of cross this out because I know it's not going to be up top. Keep this here and just write a -1 so that I know in my final answer I'm going to have a y to the second -1, which is just 1, 3y. Pretty easy on there as well. And then so here, same as this y situation. So we have an x in the numerator and an x squared in the denominator, which is kind of just like saying x squared minus 1, which again will just be x. So I can cross this guy out because I know the x is going to remain in the denominator. And kind of contrasting, this y cubed is larger than y squared, so I can cross out the y squared from the denominator. A little -2 again just means that I'm going to have a y to the first, or just y, in my final answer. So that is a y over what is just going to be an x, because we have x to the first and x squared, just x. And this is my answer, so I can rewrite it a little close together. And that's that. So applying these same 3 basic rules to this problem here, I know that I am going to need to split my numerator terms and just apply the denominator to them individually because it'll make it easier to divide out. So 18xy over 3xy squared. And here we have a plus sign, so that's just going to be brought down right here, plus 22x cubed y over, again, just the same, 3xy squared. Minus sign here, so that's what's going to go between these two terms here. That's a 15. I know it's a little odd, but it's a 15x squared over 3x y squared. All right. And so, again, referring to these rules here, I am going to divide or simplify the coefficients first. And in this first case here, it's pretty simple because 3 goes into 18 6 times. So I can cross these out. We have a 1, and that'll become a 6. And so right here, 3 cannot evenly go into 22, and it can't just even, nothing can be factored out between these two numbers, so they're just going to stay the same. These are just going to be our final answer coefficients here because they can't be reduced. Here, however, we know that 3 goes into 15 5 times, so I can add that out, and we have 5. And again, we just have to remember that this negative, it still applies here. So that's important to remember for the final answer. So then again, just like I like to, make sure that I have everything down correctly, I'm just gonna pre-write the coefficients for my final answer, which is gonna be 6 plus 22 over 3, and then again just minus 5. And finally, I'm going to go back and reduce my variables with exponents, or just apply the quotient rule. So these two x's here are just both raised to the first power. They're going to cross each other out because 1 and 1 minus 1 equals 0. Therefore, we don't have to write that that variable. This one, however, I know that because this y squared is larger than just y is going to remain in the denominator. So I can cross this guy out, and I know that our final answer will include a y squared minus 1 in this denominator position here. Moving to the next one, I know that x will remain in the numerator because the exponent is larger in the numerator, so I can think of it as, x cubed minus 1 because this coefficient is 1. So I can cross this out, and I know that in my answer, the numerator for this term will be x squared, because 3 minus 1. And then here I can cross this one out because, again, x squared is larger than, y squared is larger than y. So I can think it'll be y squared minus 1, or just y in the final answer. And then here, little fly. In the final term here, these x's and these y's are both the same, so they're just going to cancel out because they will both just equal 1 and 1. So then all I have left to do is write the results of my quotient rule variable exponent subtraction there. So I'll just have a y under here because it's the one that's not crossed out. Similarly, I will have a x squared up top in the numerator and a y in the denominator. And here all of my variables have canceled out, so we're just left with a 5. And then just to rewrite the answer a little bit closer together, (6x over y plus 22x squared over y, or 3y minus 5 is the final answer.